Alright, so, excuse me. This is last section in chapter 6, and it deals with graphing linear inequalities in two variables. Two variables happen to be x and y. If you read the text that's in red, solutions of inequalities in two variables x and y is an ordered pair x comma y, which is in a coordinate plane that produces a true statement when the values of x and y are substituted into the inequality. So basically what that means is you're going to be given an inequality that has x and y in it. There are going to be assignments that you're going to be given that they're going to give you coordinates, and you're going to have to see if those coordinates make that inequality a true statement. If when you substitute in those x and y values and they don't hold true, then it's a false statement. So let's look at example 1, and we're supposed to tell whether the ordered pair is a solution of negative x plus 2y is less than 8. So we have 4 different coordinates. We have 0, 0, 0, 4, 3, 5, and negative 10, 5. So what we need to do is we need to substitute in our x and y values to see if the statement is true or not. So I have x and I have my y value, so I'm going to substitute in these into this inequality. So I'm going to have 0 plus 2 times 0 is less than 8. So I have 0 is less than 8. This is a true statement because 8 is larger than 0, and the alligator is opening up at the 8, so this is a true statement. We go on to B. So if I go 0 plus 2 times 4 is less than 8, I have 8 is less than 8. This is not true. This is a false statement. Now if I were to have this less than or equal to, then it would be true, but for the case that we have, this is a false statement. C, I got negative 3 plus 2 times 5 is less than 8. Negative 3 plus 10 is less than 8. Negative 3 plus 10 is 7 is less than 8. 8 is larger than 7, so this holds true. Last one, we have negative 10 and 5. So we have a negative 10 goes into a negative x, so actually that becomes positive, plus 2 times 5 is less than 8. I got 10 plus 10 less than 8. 20 is less than 8. Well, that's not true. 20 is larger, so that's actually a false statement. So you're going to be asked some questions like this in your homework, and you're going to be able to see if you can determine whether or not those coordinates are true or false. Second portion of your homework is you're going to need to be able to graph inequalities. There are 3 steps in order to graph inequalities. Step 1 is we must graph the boundary line. Now the boundary line is exactly just like graphing a linear equation. So if we were to look, say, at this example, y is greater than 4x minus 3, you're graphing it just like if it was y equals 4x minus 3, because our slope is still 4 and our y-intercept is still in negative 3. So when they talk about the boundary line, you're just graphing it just like you did in chapter 4. And what I'm looking for here, the only difference is you must take a look at the inequality itself. If it has, you use you end up using dashed lines if the inequality is greater than or less than sign. You would use a solid line if it's a greater than or equal to or a less than or equal to. So if we look at this one here, it is just a greater than, so we're using dashed lines. As you can see, these ones are dashed, and if you look, my y-intercept is at -3, and I have a 1, 2, 3, 4, 1. I have a slope of 4/1. So that's where our graph comes in. Step 2 is we need a test point to see if the x comma y coordinate is a true or false statement for that particular inequality. So what I usually do is it's very important to select a point on the graph that's not on the boundary line. So I would not want to find anything that's close to the boundary line. The easiest coordinates to try to solve for is 0, 0. So I'm going to use 0, 0 as my point. So what I'm going to do is I'm just going to substitute in these values for x and this value for y into this inequality to see if it holds true or not. So I have 0 is greater than 4 times 0 minus 3. So that becomes 0. So 0 is greater than -3. This is a true statement. So if what you have here is a true statement as your test point, that means you're gonna be doing some shading, which is step 3. So it says shade the side of the inequality that makes the statement true. So if you picked a point, which we did, we picked a point on this side, on the left-hand side of our boundary line, which means if that holds true, that means we get to shade this side. If 0, 0 was a false statement, then you would have shaded the other side. Okay? Let's look at another example. Here I have x plus 3y is greater than or equal to -3. See how the greater than or equal to shows that it's a solid line? But first what I'm going to do is I'm going to solve for y. So I'm going to subtract x to both sides, which leaves me with 3y is greater than or equal to -x minus 3. I'm going to divide by 3 to both sides. So now I have y is greater than or equal to -1/3 x minus 1. So we have our equation, which it shows that my y-intercept is -1, holds true there, and my slope is at a -3. So I go up 3 and I went to the left. I went up 1 and to the left 3. 1, 2, 3. So that is our line. So now what we do is do step 2. Let's find our test point. So I'm going to use 0, 0 again. So if I were to plug in 0, 0 here, I got 0 is greater than or equal to -1/3 times 0 minus 1. And we got 0 is greater than or equal to -1. This holds true. So I'm going to shade this portion of our graph. Give you an idea of, let's say we did -3, -3. What if, say, I use that as a test point? So -3, -3, and I use that into this equation. So I have -3 is greater than or equal to -1/3 times -3 times my -1. -3 greater than or equal to. So this actually becomes 1 minus 1. So -3 is greater than or equal to 0, which happens to be a false statement. So that is why the left-hand side of left-hand side of of the boundary line does not get shaded. So let's take a look at some more graphs. I got 2 of them for you here. I got y is greater than x plus 3. So just treating it just like a linear equation, my y-intercept is 3, and my slope is at 1 over 1. So I'm going to go up 1 to the right 1, up 1 to the right 1, up 1 to the right 1. And my graph is a dotted line, so because it's a greater than, not a greater than or equal to, so it's a dashed line. And I'm going to use my test point, which is I'm going to use 0, 0, because it's the easiest. So I got 0 is greater than 0 plus 3. And 0 is greater than 0 plus 3 is 3. And this is a false statement. So my test point was wrong, so that means that I have to shade away from the boundary, from that part of the boundary line. And the last graph I have is, first off, let's get y by itself. So I'm going to distribute to my 3, so I got 3x minus 6 is greater than or equal to y plus 8. I want to subtract 8 to both sides. That cancels it out. So I got 3x minus 14 is greater than y. And I'm just going to make, I just want y by on the left-hand side, and the alligator's pointing at the 3x minus 14, so I'm going to keep it like that. And there we go. So if let's say for this graph that each of these squares equals 2 units. So my y-intercept will be at 2, 4, 6, 8, 10, 12, 14. So that's my 14. And then my slope is at 3 over 1, so it's like halfway there and halfway there. So I'm going to try to make it, this will be a solid line because it's has an equal to it. So now I'm going to use, again, 0, 0 is my test point. So I got 0 is greater than or equal to 3 times 0 minus 14. And 0 is greater than or equal to 0 minus 14. 0. And this is a false statement. So because it's on the left-hand side of my boundary line, I am shading the other side. And that is solving linear inequalities with 2 variables. This helps. Until next time.